This conference will now be recorded.
Is my slide visible? You want me to
Yeah,
resize?
but not in slideshow mode, in outline mode, in case you're wondering.
Yes, it's a PDF, so kind of if it's visible, I would like to stay like that.
Yep.
Okay,
Then
cool.
it is.
All right, thank you, Bapi, and good morning, everyone. Happy Friday. I wanted to give you an update about what CDX has been doing in the last many months and cover some of the recent activities that we're working on. I have a few slides kind of to rehash some of the work that we have done just to bring up everybody up to speed of where we are, what we have done. There's some interesting work that has happened, and also give you an overview of actually brief overview of a white paper that we're working on that is we are hoping to release sometime during the summer. With that said, for those of you who are not familiar with CDX, basically the name stands for Chiplet Design Exchange. We are a workstream under ODSA, and really our charter is to enable handoffs and workflows for the open chiplet ecosystem. That includes basically we write papers, we write specifications, we write workflows, and all of that is centered around how we integrate chiplets together. The intent is these are heterogeneous systems, heterogeneous chiplets coming from different vendors, and to do that, right, there needs to be a clear definition what's being given between users, how that's being used, and in cases where we find stuff that's missing, we would write a specification or look for contributions from participants to help us enhance the workflows and the file formats to allow that integration of chiplets into a bigger systems. One thing, a couple of things that has happened. Wanted to get everyone back to speed. Is last year we contributed a white paper for just before the global summit. That paper is part of a series of white papers on chiplet integration, and for that white paper, our focus was on the chiplet provider. What is it that a chiplet provider would need to provide together with its physical chiplet? What models they need to provide, what kind of specifications they need to provide upstream to enable integration of chiplets into a bigger system. We call that white paper proposed standardization of chiplet models for heterogeneous integration. On the slide, I have the link, and in case you get the file that's not clickable, I also have the QR code. You can easily scan it and get to the white paper. This is in the OCP database, contributions database. This white paper was written by quite a few authors, and I would suggest you take a look at that if you're building chiplets and wondering, okay, what models do I need to provide? What are they going to be used for? Right, just at the high level, that white paper will reference all of that. Just a quick snapshot from that white paper at the models that we looked at. This is the introduction table for different purposes. What kind of models are we using? Right. For example, for thermal, we have the ECXML model, which is a JEDEC standard. That's active standard that's being developed, and right now we are, as far as I know, there's a new release that will come up soon that addresses some of the missing points in that. format, but the ECXML is one format to exchange data for thermal analysis of chiplets. Then there is the physical, mechanical, and I/O description of chiplets. There's several different formats that are used and can be used to exchange data. Some of these are optional, some of these are required, and they fall into different flows depending on what exactly we're trying to do. Right. For example, JEP30 and CDXML will describe the physical aspect and the electrical aspects, while SPICE models will have a definition for things like IOs, IBIS models, and so on. Then there are the behavioral models of the chiplet. These are necessary to integrate and simulate chiplets into the bigger system. Power models, there's quite a few of those. There's Liberty, and really for describing a macro level power dissipation of chiplets, 2416 is one standard that enables to capture power at different states, different modes, different supplies. Then there's the UPF and CPF, which you would need to enable proper connectivity between chiplets. And what are the different modes, what are the different supplies, and so on. Going into power analysis, power integrity analysis, we have CPM model for the chiplet. This provides current profiles on the chiplet supplies together with internal capacitances, and you would use this to do power integrity level analysis at the package level with different chiplets integrated together. There's the electrical rules section of JEP30. Then there's quite a bit of, as you know, test is an interesting topic for chiplets. How do we do test, and what how this is connected? There's quite a few standards that cover that aspect. And being quite complicated, naturally there are quite a few standards. I'm not going to go through all of these, but you can check out what these standards are and what each one of these is used for. Then on the security aspect, optional is the security agent. That's to enable the security for chiplets. And there are some things that cannot be put necessarily into file formats, but there's a need for documentation and guidelines that kind of describes what is this chiplet and what is the overall use of the chiplet, and kind of guidelines how you would
Hey, David.
capture it. Yes.
Is this basically that Google sheet that James shared from the JEP30 working group? Is this a different way of presenting that information?
No, this is not the, no, the JEP30 is a little bit of different matter altogether.
So he shared something called a CDK checklist.
Yes, that's yes. So the checklist for chiplets is basically going to cover this, right? When you deliver a chiplet, you would deliver the checklist as well. That says, okay, so here's the this table basically kind of enumerates all the possible file formats and data that's being exchanged, but the checklist says, okay, here's my chiplet, and this is what I have for this chiplet. So that a user would know what's available and go and ask for the data.
Right. So this is the minimum, or this is is this a mandatory minimum recommended or guideline? What is the magic phrase we're using?
Yeah, so this is the guideline for all models that are available. I mean, the available file formats and data that is possible for a chiplet. The checklist specifically says for specific chiplets what models are available, right? Which would be a subset of this. Right, this is the superset of all models.
Right. So this out of this are we going to, this is a catalog of all possible models, right?
Yeah, this is the superset. Yes.
And then is this going to be boiled down to a recommended list or a minimum list of models?
There is, yes. So some of these models are required to do chiplet integration. Some of these are optional. Some of these are recommended, right? I mean, they're still optional, but it's recommended to be available,
So
right?
like,
And the checklist would then say, okay, for chiplet ABC, the actual available models are CDE, right?
so I've heard Jawad and Tony using the phrase electronic data sheet. So if there's supposed to be an electronic data sheet, which of these things would be in the data brief versus data sheet versus?
Okay, so the electronic data sheet. Okay, so the product brief will probably have a list of just of the models which are available, kind of like a checklist, right? I have ABC models, but I don't have CDE models. To give a guidance to the user what is actually available for this chiplet. Um, that product brief will not necessarily carry all the models with it, right? This will be a separate deliverable from the vendor.
So is there an overlap between, like, let's say the physical, mechanical, and IO, you have 5 model types here. Is there an overlap between them today, or they all do complementary things?
They are all complementary things.
So you could have both a library exchange format model and a JEDEC JEP30 model for something,
Yes.
and a separate Verilog to pay physical pin. They'll all be describing different aspects of the chip.
Yes.
Oh,
For example, so the example which you gave, so left will, for example, will have all the bump locations, right? Just but the left will come from the die level, right? So you can look at the pin map and see where all the pins are. But that is not enough description. So JEP30 and CDXML will actually describe for these pins, what is the bump like? Is it a copper pillar? Is it a C4 bump or something else? What is its profile? What is the ESD rating on that pin? What is the maximum voltage rating on that pin as well, right? The CDXML also will describe the physical dimensions of the chiplet itself, like die dimensions, die thickness. It will have tolerances on those as well, right? Which are not anywhere else. Spice, for example, will go even deeper, and it will describe, okay, on this pin, we have a driver that looks like with RLC like this, right? So that when you're looking at from the outside, you know what's kind of inside. You have a model for the inside circuit that then you can use to simulate SI, for example.
so
So, Bapi, Jawad here. It sounds like that there is some confusion. Maybe we can have a quick discussion on that.
okay.
So you think that there is some duplication here, right? That's
No, I'm hoping one of the things that comes out is that if there's a data brief, we have a recommendation on these are the pieces. That's the intent of all of this. That once everybody's done, that an electronic data brief has these pieces, a electronic data sheet has these pieces,
okay.
and
Yeah.
then if each of them are complementary, then it becomes harder and harder.
Right. So I think we, in CDX, we haven't even started discussing the data brief format because we had just focused quite a bit on finalizing CDXML and the integration white paper. But the data brief is definitely on our list to simplify. What's happening is when we are working with JEDEC, there is a lot that we are learning in terms of, what formats JEDEC and the PCB industry, for example, is used to. So we thought that, in few weeks, then we'll have a better idea on what will be the bare minimum that we will add to the metadata.
Got it. Thank you.
Yes.
Thanks, David.
Thank you, Jawad. Yeah. Thank you for clarifying that.
Hi, this is Suresh. Can I say something? In the CDK, I think there are two intents here, right? To create electronic formats that allow for more automation and all of this. But also, it is true that much of this information today is available in some form or the other. There are a few additional things that a chiplet integration requires. I was going to mention some of these in the business work group, but isn't what I said generally true, Jawad or David?
Yeah, Suresh. So generally, lots of technology and bits and pieces in a very heterogeneous manner do exist. So the intention here was to create a checklist and create a standard for the design kit. Thinking from the point of view of a marketplace, that if people were to sell chiplets, that they should be providing at least these models in, it could be just a collection of data under one heading. I think down the line, what you will see as we progress through CDXML 2.0 and 3.0, that some of this is going to get more streamlined in terms of how the structured data will be put together and made available in a standard format.
Got it. My point is, today, if you look at a product data sheet for any IC, most of this information is available in the data sheet or the technical reference manual, right? There are a few additional things that you would need if you're doing chiplets, which is a little bit more quote unquote invasive in terms of the details. But the bigger point, I think you mentioned electronic data sheet, to have it in a format where you could suck it into different tools and allow for a lot of automation in the methodology and design process. That's the way I see it.
That's right. That's absolutely right. So the thing is, with simpler chiplets or KGD, it's easier to encode them. But when you go into chiplets that are going to have, say, 1 million IO, right, at that stage, it's not possible for a human to be involved in it.
Sure.
Yep. Thank you, Suresh and Jawad. So we touched base a little bit on CXML and the collaboration with JEDEC on that. So CDXML is a contribution from Palo Alto Electron to OCP, and it contains important ESD mechanical and electrical descriptions of chiplets. It actually has a lot more. I just listed a few of the interesting ones. That contribution basically led to a collaboration agreement between OCP and JEDEC. And basically what is happening is JEDEC is taking the CDXML format and enhancing their JEP30 part model to support description of chiplets. JEP30 in general has been used for describing complete parts, which you would put on a PCB. So it needs to be enhanced to handle chiplets, right? The terminology is a little bit different. The data that is needed is slightly different, and so on. So on the other hand, we are, as Rod mentioned, we are learning from JEDEC about how they are describing parts, and some of that learning is going to go into future CDXML updates, so that we kind of CDXML and JEDEC are synchronized at some level. And then CDXML work continues, and as Rod mentioned, we were looking to enhance it, right, for 2.0 and 3.0 with additional data and metadata that is going to be useful for automation. There's a presentation that goes into details of what CDXML is from the Global Summit 2022. Again, click on the link or follow the QR code. James did a wonderful presentation, and I think he presented to this team as well more about the inner workings of CDXML. So in overall, CDXML work is continuing and is being enhanced with new data as we go along. Now, I think the interesting part that Bapi, I'm finally getting to what you're interested in, and that's the workflow white paper. This is something that we are working on, and I have a couple of slides just to kind of snippets of what's in the white paper and what we are trying to cover. This is part of the introduction that was contributed by Tony Mastriani at Siemens and by Jawad. And really, what we're looking for is flows for integrating chiplets together. As you know, and are learning, a lot of the typical flows which you would have for monolithic SoC, those flows have been kind of serialized, in the sense that you would start with RTL, then design your die, then design your package, then do a sign-off, power integrity, signal integrity check. In the chiplet world, we need to have flows, so-called predictive flows, that we can run at the very early stage, before even we have the final chiplets, where we can look at things at power, thermals, choices of packaging, integration, power integrity, signal integrity. All of that stuff needs to be considered early on. And so a lot of those flows which were serialized now have been brought to the very beginning, and all of these flows would need to run in parallel. So the data that comes from all the models is kind of is key to be able to enable these flows, and there's also additional tools and automation to enable the co-design and optimization and actually co-verification of systems starting at the very early stages of at the flow. And really, it's a continuous flow that you will start early. The continuous flows in all cases, where predictive flows will start with some data early on, and as we go along, we go through refinement. As new data comes in, we'll refine the data that goes into the flow and get more refined results. Really, the intent is with these refined flows, a sign-off flow should be a one-shot run, kind of final verification. That we don't want to be finding any issues at sign-off, right? There's no way to redesign or refloor plan a package at the sign-off now, right? It's way too late to do that because it impacts everything. All the assumptions for power integrity, thermals will be invalidate it if we start finding issues at sign-off. So making decisions early on is critical. That the only way we can do that is with better data and proper flows to allow refinement and correction, of course. Couple of things, as I mentioned, I wanted to show you. One is the mechanical analysis section. This was contributed by Li Hong. And really, what we are looking at here is we have 3 columns for that I would be concerned about mechanical aspects. On the chip side, right? We would develop the chip package, we'll develop the package, and system we'll look at the system what it is. The important part is this linkage here on the bottom that is actually well in the middle that allows for co-design and co-optimization. Using the data from the 3 columns, we basically we'll look to design a system, right? We'll choose what the materials are going to be, what the stackup is going to be, what all other properties of the system need to be to ensure correct and actually working system, reliable chiplet system. That is known as the pre-assembly analysis. And then once packaging and assembly happens, then we have the post-analysis that, okay, now we have chosen all these properties, we have the final chiplets, we need to do an analysis in terms of warpage, moisture resistance, mechanical stability, reliability, stresses, strains, and so on. It's actually quite a long chapter. I just synthesized it down to 1 slide, just to briefly show you what kind of flows we are looking at and what are we describing in the white paper. The next section is looking at predictive power integrity analysis. This section is contributed by Lau at Siemens EDA, and really it describes kind of step by step what you would be looking at, and you can see some of the models. For example, CPM is mentioned. CPM model is mentioned here. So excuse me. With reference to the original checklist, right? If you're doing PI, you would know what models to look for, and you can see, okay, these chiplets have CPM models, I can use them in the analysis, and these don't, then I need to go and ask the vendor to deliver me CPM models. It describes step by step how, right, what you start off with, right, the geometries, materials, assumptions, building a PDN circuit, and then going through the verification process, looking at, okay, step by step, what am I verifying, right, after I have run my analysis. Excuse me. The section describes a little bit on why this is needed, what are the impacts of power integrity issues, and why do we need to worry about that, apart from describing a step-by-step flow. Again, this is, I'm probably not doing it justice. Keep in mind I have synthesized fairly large section down to 1 slide. For reference, the paper right now is running, I believe, at 59 pages. So I apologize to all the contributors if I chopped a little bit too much of their text, but I wanted just to give you guys a little bit of preview about what flows we are looking at. Hopefully, anyone that is looking to integrate chiplets together, the intent of the white paper is to enable you to have a flow diagram that's ready to go, and you can just take that flow diagram, take your chiplets, take your tools, and execute that flow and understand what to look out for. This was my last slide on the workflow, CDX workflow work. Any questions about this? Any comments? I would appreciate that.
Yeah, so Bapi, I want to make a couple of comments here. This is more like an overview talk of history of work that CDX group has done. We'd be happy to dive deep into any of these topics and discuss that in detail. So case in point that, CDK work was started in 2021. CDXML was done last year, and this workflow is this year. So, and as we are working with JEDEC, we're learning a lot about, what they want, and that work has is quite involved at this moment, because we're getting feedback from a different organization. So in particular, if there is interest in reviewing like what kind of data structures are being recommended in CDXML as a bare minimum information, we will come back and show you those if you like.
Yes, please. I think that would be good. Thank you. Thanks, David.
Oh yeah, you're welcome. And thank you, Gerard, for chiming in.
Sorry, are you done or you're not? I apologize. I thought you.
I have one last slide, but
Oh yeah, please go
my
ahead.
PDF,
please go ahead. Go ahead.
My PDF is hanging, so I'm just gonna talk to it. It's the regular call to actions slide, right? We always welcome contributions from companies and individuals. So if any of this is interesting to you, please feel free to join and to contribute to the effort. Just in a verbal overview of the white paper, what we're looking at is that there are several sections. We are talking about partitioning, about architectural choices. We are talking about power, thermal, mechanical, power integrity, signal integrity, and DFT. So we always welcome we would welcome contributions to any of these topics. We meet Thursdays at 10 a.m. Pacific. And you should all have been receiving notifications about the meeting setup. So feel free to join us and to help us out. That's the last thing I had, actually. Thank you. Am I still on the call? Or
Yes.
okay, all right. My computer is hanging, and I'm not sure if I'm audible or not. Okay, so that's the last thing, Bob, for me.
All right. Thank you.
Oh, you're welcome.
Okay, any questions for David?
Bapi,
yeah,
I believe you should receive email shortly with my slides, so please feel free to share with.
Yeah, I'll share that to the group. I think you can email it to the group as well, but I'm happy to do so.
Okay.
In fact, I'm reasonably sure anybody who wants to can mail the group.
Okay, let me try that then.
All right, Marek, it's all yours. So we'll split the discussion into 2 parts, maybe a summary part of everything we've learned, and then I'll do a new recording starting 9 a.m. Pacific. Marek, is that okay?
Sure, sounds good. Okay.
It's all yours. Then
Great.
here, I'm going to make you the presenter as well.
Awesome,
I'll make you
thank
the
you.
organizer. It makes life easier.
Okay, let's see, so. Okay, can everyone see my screen?
Yes.
Okay, great.
We can, no, Marek,
So,
yep.
Okay, so let me go. So what I did for this short presentation was to just go back the last couple meetings and summarize the essence of what the various companies had discussed in terms of what their challenges are from a business perspective. So the first thing I did, and I'm happy to send out these slides afterwards as well, is to just collect all the links here from the various talks. So you can see here the 9 companies that gave a talk, the presenter of that talk, when it happened, and then the YouTube link that's also timed to the time in the recording when that person started, as well as the meeting minutes. So I think this is just good to have this information. And so then the next thing I tried to do was to pick out the most important, like say, observations from each company in terms of things that are missing or things that are currently presenting a challenge. And that's kind of presented here in this table. So for some people, I had to condense this down because it wasn't, there were many slides for some of these presentations. For others, it was reasonably easy. And then this color coding here is, I tried to find things that are in essence the same thing, but may have been phrased differently. So that then brings me to the actual overview or summary. I try to put this into 3 categories. The first one is our business related issues. And I wrote down the things that I found, as well as the count of like how many companies have said something along those lines. So for business issues, the biggest one that came up with 6 counts is something around the cost benefit of chiplets versus monolithic, as well as the cost overhead of having chiplets, which is, I guess, maybe two sides to the same medal. Then the second item was production schedule uncertainty or risk associated with chiplet design or chiplet architecture. And then 2 counts each were for the upfront cost required, and also the capability of being able to just develop your own chiplets, the responsibility of the final product, who would have that, especially when you think about building chiplet systems with chiplets from multiple companies, and then the issue of confidential disclosure, again, if you're thinking about collaborating with others or even having this open marketplace. Are there questions or comments about that first block of issues?
Yeah, actually, it's Cliff. I like what you did. It makes a lot of sense, and I would have done pretty much the same thing. There's 1 or 2 things that I thought I heard around looking for standardizations for form factors and looking for standardizations for checklists to know that that someone could test against to prove that a chiplet meets the, I guess, electronic data sheet. That's not showing up here. Is that just a factor
Yes,
of how you type
I guess I can fast forward. There's I have a big, I did put this under kind of the technical section, the standardization, but yes, I did capture that. So yeah,
I always like it when someone asks me for something that I've already done. So perfect.
Exactly. Yeah. So the second thing that it's a small group, but it's something related to the marketplace. There have been a couple of companies mentioning that if chiplets were available, like different functionalities and available in chiplet format, that would in turn help them start incorporating them into products, and that's certainly not true today. And then also people have mentioned that there is just not an open marketplace for chiplets yet, and that's holding them back. And then the biggest section, I would say, I listed those as technical related items, but they're still also business items in a way that if those aren't solved, you will not be able to easily offer business or chiplets to other companies. So some of the things that came up there in terms of the ones that most or a lot of companies saw was the choice of die-to-die interface. Some people have said this in terms of should we use a bunch of wires or UCIe? Others have left it more general, but I think this is on a lot of companies' minds. 3 companies mentioned something along the lines of understanding the best packaging options, be it standard packages like laminates or more advanced options like interposer. There were also 3 companies mentioning something about standardization. And I just put in a couple of examples here. Not everyone mentioned all these things, but having standardization towards the link layer, understanding power or voltages, and maybe having standardization there, as well as aspect ratio and probably other standardization as well. Then there was several people mentioned that IP availability in several nodes as IP for die-to-die validation and other things would be helpful to have to accelerate chiplet adoption. And then with 2 mentions each was knowing the die solutions, chiplet security or root of trust, ESD protection, and having an interface that is either scalable or that goes towards the less bandwidth area. Any other questions on this quick summary here?
Yeah, Marek, so
yeah.
Where would the concept of a standardized checklist against which we could validate a chiplet be in your list?
Yeah, so I think that again brings me to my last slide now.
Oh.
Yeah. Oh no,
you
go ahead.
Come back to that slide, right? I
can come back to that one. But maybe I'll just fast forward to it here. I have been thinking about the things that we mentioned so far of ideas that we could work on in the business working group. One being the checklist, and the other one being organizing information. And I tried to map what these two efforts would which items they would address of the challenges that have been mentioned. So I think this checklist and self-compliance testing would help with the third-party chiplet availability, because it would mean that people could have a way to say that they're compliant to a certain standard. It would help with the confidential disclosure, because you would be able to create this entity that tests chiplets without necessarily telling your business partner all about the details of your chiplet. It would help with die-to-die choices and with standardization. So that may answer your question.
Okay, I might quibble with your putting that under technical, because
okay, yeah,
but that's a small matter. The other element that I wanted to put on the table was the concept of establishing an open marketplace, and that's also something that the OCP would be willing to look at if there was community support for that. So you might want to consider adding that here as a low-hanging fruit at the right time frame.
Yes. Okay. Yeah, that is a good feedback. So let me
we already have a marketplace for products, and it wouldn't be a very difficult extension to have a section on chiplets.
Yes.
I have a question on the technical or business. Is that the question of whether it is a strategy to go into chiplets, or whether it is just putting a toe into the water?
Yeah.
I think it's a combination of technical and business in terms of the strategy question.
That is a good observation. That's certainly true. That if it that there is a strategic component behind it, and without it, it's going to be difficult to make enough investment to have an impact or even get a return on what you're doing.
Can you go back one slide if you don't mind?
Yeah, of course.
Again, I think the community needs to make some choices, but if I look at the cost benefit versus monolithic versus cost overhead, did you wrap it under the checklist? I can't recall, but it seemed to me there might be another work product to think about, which was some sort of best practices example, business case. There was a lot of discussion, I recall, around reuse of chiplets, and unless you got to a certain point where in your business plan you included the ability to reuse chiplets and across different product lines, it probably wouldn't work. And so where would we capture that learning? Is there a place where we could create a document or some output that captures that learning as a part of the business work group at some point?
So by that you would say either like describing example thought processes so that people can see like what to consider when making that decision. Is that maybe something that you would capture?
Exactly. Let's say I'm a product line manager, right?
Yeah.
And I want to go and convince my management to go ahead and go to chiplet approach, right? So I have to build a business case.
Yep.
If I could have an example, even one that's not specific to giving away anybody's intellectual property, but is structured around someone or the community having done some successful business cases, as they'd say a pro forma business case, maybe that's the right word, that I could then use internally to create one that I know all the sections that need to be in there and what are the questions I should ask in order to create one that's typically going to succeed. That would probably help me rather than starting from scratch.
Yeah, that is a good idea. I wonder how much of that information in there can be generalized, or if it's not generalized, can still be shared because it's either old enough or public enough that it's okay to be in such a public document. But because I feel like the questions, if you have an example, like how much does it transfer to your own situation? But I agree that having a couple of examples to look at and seeing why they arrived at a certain conclusion would be helpful.
Exactly. Even the ones that failed could be helpful, because then people can think about how they might approach it differently. So I kind of thought it might be good to have that as one of the options to consider for the business work group going forward, considering there was such a large discussion about attempts that didn't succeed. And I got the feeling we could potentially make a difference as a group. And we'd be the group here to help the community understand how to overcome that barrier.
Yep,
Just a thought I wanted to put out there for you.
Mm-hmm. Any other thoughts on these items here, or any ones that you feel strongly about that should be on here?
There are three things. One, thank you. This is exactly what we needed. A huge thank you. A sort of a summarized list like this takes a solid amount of effort to wade through all the notes. So
I agree heartily. Thank you, Merrick. It's non-trivial to pull all that information from all the talks. So appreciate it.
No problem.
That's number one. And number two, and maybe we could do this offline, is whether we could take these and map these to things that we've already done, or where we've already done and there is a starting point. That's or things that we could sort of reach out to other organizations like Bill Chen's group or something.
Mm-hmm.
And the third question I have is do you think that, when people are saying technical, they meant technical as it impacted business, or technical as a purely standalone geeking out technical choice?
I mean, I just put this in myself. I think most people, this was all under the umbrella of business challenges. So just to not have it all in one big list and say this is all business. That's why I put in this term of a
Got it.
like technical or technically related issue maybe.
It's a tech, but it's fundamentally a way. It's an impact to doing business. It's not like
Yeah.
That's your understanding.
Yes. Yeah.
Thank you.
So even when going to something as specific as ESG protection, I think it would all, like, if that were in place and people fully understood how to do it and knew that it was safe in a way, then that would enable you to, like, or at least you could take that off your list of worries when trying to offer chiplets at a market, like on a marketplace.
Got it. Okay. Hey, it's 8:58.
Yep.
I feel like this is a good place to stop and transition to the next meeting. So I'm going to stop recording now, and we start at 9:01 a.m. so that we have 2 separate recordings, and you can sort of rehash this first slide.
Okay, sounds good.
Does that make sense?
Yep.
Okay, I'm going to stop here.
This conference will now be recorded.
Okay, so I will start the business working group with the overview of what we just saw at the general meeting, which is a summary of business challenges extracted from the various company talks that we've had over the past 2 months. So let me share my screen again here. Okay, so I know that most of you have been in this call before, but for the ones that haven't been there, what I did was just try to summarize the various talks that we've heard, and I started by first having an overview of all the talks and the presenters, then went to pick out the main challenges in separate arguments in these columns here, then color coded them based on things that sound similar, and then as a result of that, counted, like basically put them into this table here and counted how often somebody said one of these challenges is a thing that they are concerned about. And so the main ones that I guess stand out on the business side are this whole question around cost benefits of chiplets versus monolithic and the additional cost related to building chiplet systems, and the schedule uncertainty. Then here are a couple ones that were mentioned 2 out of 9 times. The chiplet marketplace, 3 people or 3 companies mentioned it would be nice to have chiplets available at or third-party chiplets available in general so that they could start incorporating them into their own products. And then the most important, like technically related issues are the question of which die-to-die interface to choose, and I guess what ecosystem are you aligning your chiplets to, what packaging options you should be using, the question around standardization and this would be various aspects, software related as well as hardware related, and then also IP availability so that you can build your chiplet and that you don't have to develop everything from, say, the die-to-die interface and validation as 2 examples. So this is a quick overview again. Any questions for the people that weren't on the previous call?
And this is basically a compendium, right, of all the summary of the minutes, essentially, whatever they presented.
Yes, exactly. And I did put in the slide, or I didn't put in all the slides, but the most important slides from these various companies below here as well, so that if people want to kind of drill deeper, then they can go back and look at that as well.
So my question is, given all of these, what is the upshot that we can make progress, or what is the priority or focus? How should one think about this?
Yes, yeah, that's a great question, and that just came up. Cliff was asking that just before. So I think how can we basically go from challenges to thinking solution oriented and making a difference here? Bobby had suggested as one item to do now is to go through that list and think about all the existing work that has already been done in the ODSA, so that we can, at least that we know where there is a starting point, or things that where we can at least put out the reference and say, you can look there, and maybe that clarifies some questions or helps with the challenges. And then the other one is like, what can we do now about this? And I try to think about the two or two of the topics that we discussed before in terms of items that we can work on in the business group. One being this this chiplet checklist, and the other one being to organize information that the ODSA provides, and possibly also other material. And I basically put in here underneath the kinds of challenges that I think those projects would address. So the checklist, I think, would address quite a few of the things that are being mentioned, helping with standardization, die-to-die choice. If we are able to have this checklist so that a confidential party can do the testing, then that also helps with the disclosure question, and should ultimately help with the establishing a marketplace and having third-party chiplet availability. And then the giving access to information, I think, would help with the cost-benefit analysis and product schedule uncertainty. And Cliff was mentioning that one thing that we could maybe drill down on is to better document the kind of past chiplet endeavors by companies, like information that are either already accessible on the internet or kind of at an abstracted level, like basically compiling best practices and past experiences. And that would also help with these items here, I think. And that's something that we could probably also attempt to do in this working group.
Marek, whenever you have a chance, I have a couple of slides that I wanted to share with this group.
Yes.
And
yeah.
Also kind of probably it'll help answer some of, in my mind, even with the CDX, it's a great initiative, but prioritizing and saying where should companies focus, what is the most urgent, and that sort of thing might actually get some traction, because all of those things to produce those standards will require, or standardized format will create enormous friction and inertia. So whenever it's appropriate, I'd like 5 minutes to share that, or 10
Okay.
minutes.
Sure. I mean, so I had written down kind of the things that we could talk, or just like recapping from last week, what we had talked about. So it sounds like this also part of this checklist effort where you said last week that you would be able to take a crack at that, or is that independent of that effort?
Yeah, it kind of, at least the straw man, and I wanted to say checklist versus what's the state of the art in how people do things.
Okay.
And so why how to prioritize what matters, or even some of the business questions about access to information, right?
Yeah. Okay. Then let me make you the presenter. So, okay. You should be able to present now.
I just share my entire screen. Can you guys see my screen?
Yep.
So I borrowed this slide from Nathan, who's from AMD. He presented this at Hip Chips a few weeks ago, but it kind of, from a systems company, IC company, it kind of frames what the issues are, right? So the buckets he's using are obviously die-to-die, which is the electrical, physical, and then at the protocol level. Then power and thermal, all of these things are on the CDX checklist, so to speak.
Mm-hmm.
The other, of course, is when you have multiple die and they have their own controllers and this and that, what kind of firmware and software do you need for all of them to play nicely or do discovery, bring up that sort of thing. Security is a whole other beast, but manageability is just what I mentioned, configurability, real-time management, in-field debug, test, all of these things, right? And then the other stuff is around how things you get from one place to another, if you're getting stuff from different foundries, and then final assembly and test. These are kind of the broad buckets. And then what I tried to do was, well, one thing we should not lose sight of is today chips from multiple packet chips get assembled on PCBs. SIPs have been designed for decades. So somehow that information is getting to, there is some integrator, whether it's an OSAT or some other company that is putting all this together. That information is being shared. So this is, I also mentioned this at the previous meeting. Most of the information you do get from standard data sheets and tech ref manuals, which are in many cases fairly detailed. It's just not in an electronic format that's consumable with the various tools. You have to pull the relevant information and use in your design. And even here, sharing modes, for example, you can never find a Broadcom data sheet if you just go to their website. You have to have permissions and you have to log in so they know exactly who downloaded what and all this stuff, right? So they have their own security measures and so on. In my mind, what's really different from a integrating chiplets is you need some new types of information which normally you don't need when you're doing at a packaged IC level. But for SIPs, you would definitely, which is what are the die XY dimensions? What if it's single or multi bump pitch? What are those? With bump list, another critical new information is die thickness. Even the bump structure and the solder cap makes a difference to the OSATs in terms of if it's coming from, if the bumping is done at a fab or the OSAT is doing, they have different levels of flexibility. So all of these are critical information that, and we have faced this even from a single foundry. These are kind of the new pieces of information that I think are missing. From an assembly, there is talk, at least in some EDA vendors, of the notion of an assembly design kit, because when you're putting multiple chiplets together, there are rules around spacing and how many you can fit, which translates to manufacturability, warpage, and all of these other things. So you need all of that information. And that's kind of also in your technical column. David mentioned it in the CDX. This assembly design kit, traditionally, you have to talk to the OSATs or get their technical rules. You have to incorporate that into the tools. It is done, but it's all inefficient. So the question is, these are kinds of the new pieces of information that we need to integrate chiplets, but a lot of the information traditionally has been available, not in a let's say electronically consumable and efficient standpoint, but it is there. So I want to try and calibrate against all the challenges that you just mentioned to say what really are unique to chiplets and how do we address that. That's the main point I wanted to make. Likewise, for KGD, in terms of testing, typically the pinout or the data sheet will say what kinds of things you have access to. Final assembly, again, I think there is OSATs or what I call chiplet design integrators. That's a new kind of service or function that will open up, I think. And then again, on the firmware side, people do provide that for various chips, but at the chiplet level, what additional functions do you need out of those for discovery, configuration, management, debug, whatever may be the case, to be able to access features inside those chiplets to enable some of those. So those are kind of the things I wanted to throw out there in terms of what exactly is the difference compared to current ways we put systems together. Multiple ICs now translated to multiple chips. And I will stop here.
Okay, so you're saying basically like looking at the boxes again, that the top boxes and the ones to the right, those would be new information, and you're arguing that there's a lot of information in standard data sheets already, and if that were in an electronically readable format, then that would address some of the things that you would otherwise need.
Right. The availability in electronic format, as we discussed in the previous call, improves the efficiency, allows for better analysis methodologies and all of that stuff. But much of that information is available today, is my point. And more importantly, specifically to chiplets, the things that the kimono that companies need to open up are specifically in this area, which typically you in a data sheet you will not find this, and that's only available to whoever is doing the package design or the OSATs, right?
Okay.
They are under NDA, whatever, so none of that is publicly available. So if somebody wants to do chiplet integration and it's fair for companies to kind of guard this information and release it on an only as an as needed basis. But for that, that's why I mentioned the Broadcom model, where none of their data sheets are really available unless you register and sign in, and then they watermark it and put all kinds of caveats on it. So that's where they protect the IP.
Okay.
So Suresh, quick, just a question to understand what you're trying to say here. One is there's several levels of data that can be supplied by a vendor, right? One is just a checklist about available models for a given chiplet, right? That they give you the product, kind of like what the product brief is, right? They tell, hey, this is a say network switch chip. It has this many interfaces. Oh, and by the way, we have models A, B, C, D, right?
Right.
That's the very basic level. Then the next level is, okay, what you're describing here is, okay, here's the chiplet, and by the way, its dimensions are so and so, and then this is what the solder caps are. And then
Right, David, let me interrupt for just 1 second. The product brief typically is bare bones, tells you what it does, but the data sheet and the text reference manual goes into all the gory details. They might give you package models, they might point you to BFM, depending on, like, bus functional models and all of that is mainly at the RTL level people use.
yes,
So all of those information, in my mind, in your checklist that you had, many of those pieces are available today to designers. It's just as Jawad said, it's not consolidated. Uh, there are still BFMs have standard formats and so on. So what I'm trying to at least question or challenge is, what about chiplets is different? Yes, process is inefficient and so on. What are the missing pieces? And then beyond that, how do you enable companies to incrementally support that CDX model
okay.
in terms of priorities so that they know where to focus resources and get that information out?
So some of this information which you have mentioned as missing in terms of electronic format. So the format is there, the data is there in a PDF. So if I understand you correctly, the challenge is how do I get it? How do we get it into that file so that it can be used? Is that what the challenge is?
Correct. The companies have whatever their process is to generate the data sheet, right? But for example, IBIS is a standard for signal integrity simulations of IO drivers and all of that.
Yes.
So companies have methodologies where they characterize it in SPICE, and then they have tools to translate that into IBIS, and then they release that IBIS. But all of that, because of the support nightmare and so on and so forth, that is a commitment that they make, and they also want to make sure they're not getting a million questions and all of this, right? So what I'm trying to say is, in that checklist, which ones are most critical and how do you prioritize and provide a framework in which how companies can deliver, and it is a demand from hundreds of customers, it will enable them, only then they will do something about it.
Yeah, I just wanted to add that there's a real world, right, where a customer says, hey, I'm thinking of, let me try this chiplet stuff, and he needs to know what's even out there, right, and the general basic information. But the main thing that each one is going to have to do is go call up Broadcom or Acronix and say, hey, I hear you make chiplets, and I want information. And I think if you think that it's all going to go into some magic database and everybody can see everything, I just don't see it, right?
Agree.
It's just not happening. I see tremendous value in this CXML once the customer has decided what he wants to use. He's got all the NDAs in place. He's sold Broadcom on, hey, I really want to work with this guy, and then they'll move heaven and earth to make the customer successful, right? So there's tremendous value I see in what you're doing when you actually are trying to do the design, right? You've chosen the chiplet vendor. Chiplet vendors are not stupid, right? They're gonna have all the models that are needed, because if they're in the business, right? I mean, so it's going to be a natural process, and I think that the work at the back end, which is to drive the predictive analysis and how do these chiplets really work together and so on, that's obviously very, very valuable, right? Because people are trying to build those workflows. But there's the sales marketing workflow that isn't really thought of in this, right? And I think Suresh made a very important point. Some companies, and Broadcom is one of them, if you want a data sheet, it's not as simple as just logging into the website. They say, do you want to, they get all your information, they say, do you want the data sheet? And then what comes back at you is really a product brief that has really very little information, right? And then you're like, you scratch your head, and then you try and find a sales guy or a distributor, or it's very, very complicated, right? And it's just not trying to get pricing information. So you're going to choose, let's say there are two chiplet vendors, right? You've got Broadcom, and then you've got Marvell, let's say, right? Okay, now you want to make a decision. You want to know the size of the die, you want to know, and so on, but you also will need to know the price, right? You want to know what has it been, here are the other chiplets, has it been checked against these other chiplets, right? You're not even going to get to this level of information you're talking about until the guy who's going to put these chiplets together has got to go through that right, from a business standpoint. So if I'm now saying, okay, I'm going to choose and use chiplets, then who are the vendors? What is the cost, right? Your engineering team, if you're a manager or running a business, is an extremely valuable resource, and typically it's a limited resource, right? So they're not going to start tying everything together and running simulations and IBIS models and all of this, right? Until you pretty much know what you're going to use, and you've already kind of engaged with that vendor, right? So I mean, maybe in 10 years things are going to change, but I think that in terms of the current world today, it's very, very different.
Yeah, so that's correct. Definitely, the work that's been going on kind of tries to address, and actually has addressed. Okay, I have decided what kind of have decided what I'm going to use. Give me all the models and give me the flows to integrate that. And I think, right, it's a chicken and egg problem that you're describing, right? How do you build chiplet systems until you know what the chiplets are there that you want to use, and but if you want to use them, you kind of have to know the pricing, and then later on start with the whole integration. Now, I think there's, in my mind, chicken and egg problem. I think the way it's going to happen is we are all going to start with one baby step at a time, integrating chiplets from vendors we know that we have heard about, that they have these chiplets, or from their websites. And
David?
then, yes.
Sorry to interrupt, but one thing I would say is, to the question you raised, you first have to have, if you're doing a chiplet-based design, you have to know what is the system you're trying to build. It doesn't, let me look at all the chiplets there are and decide what I want to build, may be not the right approach,
Right.
right?
Right,
No.
right, right.
What I'm trying to say is, no, I wasn't trying to say that. I'm sorry if it came across that way. Maybe my coffee is still kicking in this morning. So definitely not, right? Where you look at what chiplets are there and kind of try to build something out of that. What I mean is, I'm not sure how to rephrase this, but basically, I think that
Think about how we do PCB-based systems today, somebody has something, they want to build a system, and then they say, these are the features I need. In some cases, they might already know which processor families and so on and so forth.
Yes.
They know how to drill down and get that information.
Yes. And that's exactly the thing I'm trying to say, is that really, when you look at what components you want to, what you kind of know what you want to build, and then you look up components, right? Who is supplying these components?
Right.
The fact of the matter is that work had already started a few years ago, right? And people have looked it up and decided to deliver this kind of component because it will be used. And really, at that stage, when they decided to deliver that, they may not even go public. They may go to the special customers and to deliver these chips. So the work on that had already started, right? What you're
What do
talking
you mean
about?
by that?
What I mean is, you already have kind of you already, as a vendor of a chiplet, you have decided that this is the chiplet you're going to build, right? And you may have already built it.
No, I think Suresh is talking about the end customer, right? He's going to build an Ethernet, switch with, some special data processing added to it or whatever, right? So then they're going to focus on the who are the switch vendors, who are some of these other, you're not going to go to a central site and say, oh, look, let me look at all the chiplets, right? So I think that's the point. There's a lot of conflating here. If I'm developing a chiplet, right, it's a completely different discussion. He's not going to care about any of this CDX crap, right? He's gonna try and talk to customers, figure out what do customers want, right? And he's gonna then talk about to his partners, because that chiplet's gonna need probably external IP. It's gonna need, is it a bunch of wires? Is it UCIe? Is it something else? Is it what type of packaging? What type of bump maps? Typically, they only have access to a limited number of foundries. You can't just go build a chiplet in 10 different processes, right? It's incredibly expensive. So that's what you're focused on, right? Is there a market? What can I build it for? What's the volumes? Who are the customers? All this other stuff, like a model, that comes after I've done my design, right? Then I have to go generate an IBIS model, address the testability issue. I want to know, how do I make it interoperable? All that stuff that developers were worried about, right?
I want to add one more thing. So I had a ringside view of some things that were happening at some large companies. So initially it was all in-house, and then more recently at Hip Chips, one of them talked about, hey, we have our own set of chiplets, but we're starting to look for third-party chiplets. So I think in our system, we're going to open up a slot. And what that means is they're going to tell companies, we are going to use, in their case, most likely UCIe, and then we have die size of so much. We're either looking for some flavor of DSAs. So that's going to generate some interest, and other chiplet vendors are going to respond to it and see if it makes sense for them to go do that. And so in some ways that is going to organically evolve. Vetting all of that up front, I don't know, might paralyze us, is the point I'm trying to make.
So it sounds like from all this discussion here, which is really very helpful to me, the points that I'm getting is that there is a lot of information, like kind of what David had talked about in the previous hour, but you guys are now saying a lot of that information you really only need once you kind of decided that you're going to go with a chiplet that you want to integrate, and at that point you need to know, and maybe you don't need all of that when you're just surveying. And so one question I had, kind of coming back to the checklist, is it sounds like there may be, if we're thinking like the original reason I think we talked about a checklist, what was the compliance, like being able to go to a marketplace and say, I'm compliant with a bunch of wires or UCIe, what is the information that you would have to provide to get that done? And so that we can tell that specific test company that they please evaluate based on these data sheets. And maybe that set is more narrow than like all the files that we would need if you actually want to integrate a chiplet into your own solution. So I'm wondering if you guys see it in a similar way, and whether we should maybe focus the discussion on what is needed for compliance testing, given that what David already discussed is basically what you will need eventually, but maybe you don't need all of that initially.
Okay, my 2 cents. Today, that marketplace could be a distributor, right? There are a number of distributors, different people have different line cards and so on. So if you have a system in mind and you want to go look at various options, you would go to a disti website. That's your marketplace, and you're going to, whoever has, if it's commodity chips, they're all out in the open. If it is some protected like Broadcom and all of that, you have to go through the rigmarole. So that's the marketplace model. What is different from what we are proposing as a marketplace?
If I might jump in here a little bit.
Yeah.
I think the distributor is not a bad term, but probably aggregator might be a better term. That's how the OCP marketplace works today. We actually don't host any specific data sheets or things like that, but we are an aggregator, a place where people can come and browse to see what's available in terms of OCP recognized equipment. But from the OCP marketplace today, when someone's interested, they actually click through to the vendor's website on a link supplied by the vendor to us. So that's a base model that we have today that we can expand upon. I like everything you're saying in the sense that maybe at some point there will be a catalog that's hosted by the OCP, but the contents of the catalog are maintained by the chiplet vendor. It might be that the chiplet vendor has things that are very highly secure, need to be highly secured, and in that case, it would be a link back to the chiplet vendor's portal where the person would log in or some way get a way to get what they need. But the OCP could still be a front end to help get that launched.
Okay. And Cliff, in that model, for somebody to list their chiplet or even link back, they have to meet the checklist. That is the objective, correct?
That's to be decided on what the criteria would be for that model. We could have some area of the marketplace where anyone could post. We could have some where it's got a stamp that the chiplet's been, this checklist has been met by self-certification. We could even, sorry, we could even think about another badge where there's been a third-party verification of the checklist. So it's for us to decide. We have flexibility here.
Okay, so
yeah, just a quick comment on CDXML, just to clarify a little bit about its contents. So the CDXML right now, the work group is looking to add the checklist in it. You don't have to provide IBIS models. You don't have to provide die sizes. These are all optional items, right? So the CDXML, one of the enhancements that came out was to add the checklist to that, so that people can say, okay, this is what's in my checklist, kind of like a product brief. This is what my chip is. This is what its interfaces are. And by the way, I have these models, right? This is the basic electronic data sheet. So that CDXML, you can easily load in a catalog and search it and do stuff like that. Now, next step is if you want that chiplet and you want to know the details, you would go to the vendor and you would get the more detailed version of the CDXML, which is going to describe dimensions, bumps, bump structure, and all that stuff. Is that what you guys are talking about?
I think that's actually quite close, I would say. I think the nuance that we had was like what information, if you wanted to enable chiplets on a site, like for example, possibly at the OCP site, and then say this chiplet is approved like UCIe or a bunch of wires, what information would need to be provided or has been checked by somebody, even a confidential party that has checked that the chiplet meets the certain requirements, and what requirements should those be?
Yeah, right now, so I guess that's a language description, so I need to clarify that. So when we say CDXML has mechanical description and electrical description, I think the proper way to say that technically is being an XML, the correct way to say it is that the CDXML can have that kind of description. It supports it, but it doesn't necessarily need to have it. So a stripped down version of CDXML would be just a description of the chiplet, meaning verbal description, text description that says, okay, this is a CPU chiplet and it has this kind of interfaces, and then checklist what models are available for that, and maybe a checklist for what interfaces are on that chiplet, right? And what IP. So say, for example, if you're looking for a chiplet with RISC-V core on it and UCA interface, you would just search for that and it will give you back the chiplet. But it doesn't have to have all the mechanical description, all the electrical description, and all of that in it, right? That can be followed up with the vendor that can give you that information.
Just maybe, like, since I have no idea how this works in practice, like, how would you even create such an XML, CDXML file? Is there like software, or is there like kind of like things with a drop-down menu so that you know the options that you could put in there?
Yeah, there's a software to generate CDXML. I don't expect people to start writing XML tags and all that stuff, right? There's a software, you go in, type in what your information is, and then CDXML pops out. Or on the reverse side, you have a CDXML, you put it into that software and it gets loaded, and then you can go and do searches.
Okay, and what is that software?
It's a web-based software that that anybody can come in, generate, or upload CDXMLs.
Okay.
Out of curiosity, where's that software hosted today?
I don't know.
Okay, okay, let's take that, if you don't mind, let's take that offline in terms of, is that something we make a contribution to the OCP and put it in our GitHub and all the rest, and version control it, and make it source if that's what we want?
Yeah, let's take that discussion offline and then see what we can do about it.
Okay, awesome.
Hey,
Okay, so it was already very helpful, David, to have you in the call today. I think this was just the right timing.
Yeah, I usually have conflict at this time, not today.
Okay.
So.
Bobby, you were going to say something?
Yeah. So there is one. There's no non-rude way to say this, and I don't know how to say this, so I apologize up front for getting everybody mad. But I believe there is a danger that we're getting caught in the list of things we could do, and not in the list of problems that, what are the specific business problems that we want to solve? Are we trying to solve a early stage chiplet design business problem, late stage chiplet business design problem, or something along those lines? We're sort of doing a deep dive into things we could do already, if that makes sense.
Yes, yeah, no, yeah. That makes sense, and it's definitely that's what's on my mind too. How can we take this discussion and focus it on something where people can actually work in groups, or we as a team to produce something of value?
Well, typically when I want to solve this kind of problem, I write out a use case. So if the use case is XYZ chiplet, XYZ SIP build, integration, then what are the stages of the use case? What is the information needed at each stage of the use case? Who are the actors? Describe the use case, and then you've got a problem you can attack.
I agree, totally agree with Cliff. Against all those business problems that you listed, Marek, studying a use case and saying which of these is a problem might resolve many questions.
It certainly would help us prioritize.
Yep.
Yeah. So then how do we pick those use cases though? Because there are probably many.
Well, that would mean typically what you want to do is list what we think are the top N use cases and rate them based upon how frequent or common they are in the industry, and that gives us our plan of attack.
Can we go back to that list? Can you display that, Marek? And then
Yes.
Yeah, what we might want to do is try and choose like the top 3 and then say, okay, next week we're going to focus on this one, the following week. I'm just as a suggestion, right? That way.
But Cash, the only thing is that list is not a set of use cases. That's just a list of things we could do. Do we not want to overlay a use case?
No, I think it was a list of, I think there was a lot of issues with what are the main issues that people are seeing with the chiplet space, right? From a business standpoint. I think it's that list that I was interested in.
You're talking about this one.
Right. There's a business and technical, right? So maybe we just look at.
Hey, Kash. So sorry, I just one thing. Hey, Marek, I knew there's one other thing that it was worth laying out these issues also depending on when in the product cycle they were experienced.
Okay. Yep.
Like, is it in the design exploration phase, in the early architecture phase, system architecture, market selection, volume manufacturing, whatever, that where we saw each of these happening.
That is a great idea.
Sorry, thanks. Sorry, Kash.
Yeah, I actually wanted to ask a question about this list, and that is, for example, the cost benefit versus monolithic is very important discussion. And what is missing in the cost model spreadsheet today that is not addressed that made this rise to the top of this business discussion, for example?
So I guess I've looked at this spreadsheet myself, and I think one of the issues is for me that like to get all the information, like especially when you're thinking like, for example, packaging is one of the things that that may impact the full factory cost. And there are like you would still have to basically understand like what packaging solutions would work. So you have to get like talk to a packaging engineer and then actually get quotes. So that is like the spreadsheet itself doesn't solve that.
Correct. So,
let me, because I actually paid a lot of attention to what they were saying. So if you take a company like NXP, right, or Microchip, right, or a whole bunch of semiconductor companies, right, they're in the business of, there's a business plan per product. They are analyzed, what the cost is going to be, what the die cost needs to be, what the package cost needs to be, right? So, and it's typically, I think one of the guys was saying it's typically like a 2-year project, right? And they know everything. They don't need some stupid thing to letting them know what the wafer cost is, what the yield is, or what the packaging cost is. They know everything, right? And how to test it. So they were finding that when they looked at it, right, and I've heard this from a number of people, that the cost of implementing using a die-to-die interface, right, because inherently a die-to-die interface starts running at 4 gig and it can go up to 16 gig per link, right, as an example. That may require, a more expensive substrate, for example, right? So if you're trying to build $1, $2, $3, $4, $5 parts, and there's a lot of those, right? And I don't know, one of the vendors was saying they may have hundreds of thousands of part numbers and variations, and I mean it just goes on and on, right? So they make a bunch of SKUs out of that, standard die that they do, and that was the big block. I mean, I think that is Anu still here? I think it was her guy.
She wasn't able to join today.
Okay. I don't remember.
Who runs away at the first sign of trouble? Remember that. Oh wait, this is being recorded. Sorry, never mind.
But why is this particular question under the purview of OCP, or it is something that companies have to grapple with, right?
Yeah, there was a general comment made at the Chiplet Summit, and I kind of mentioned it in the serialized flow that I was talking about. But I think what you guys are finding out is that deciding on stuff upfront has gotten much harder, right? You need to consider all these things which were later on in the thought process, right? Say for monolithic die, typically it was okay. I'm going to put down this many SerDes lanes, and I'm going to be good, right? And you design your die, and then you still have the option to modify the package to some extent, right? How many layers you would need, what kind of substrate. But now we are finding out that pretty much early on, when you're deciding on a product, you have to nail down what the substrate is, right? And the comment that was made back in the days, I think by Anu by Anu in the business group, is that, you know what, actually even the packaging houses are not set up right now to commit to a specific substrate or pricing that early on, right? They typically would expect a little bit more solidified design, and then they can tell, yeah, we can do it or can do it. So I think that's a general problem, very interesting problem.
David, I have to disagree a little bit. The thing is, if you talk to the OSATs and all of this, it's not that you have to commit up front. It again, everything boils down to what Cliff said before. You need to have a use case. From a package standpoint, what is it that you're trying to build? How much bandwidth do you need? How many such interfaces? That is going to push you towards a certain packaging solution. It's a multi-dimensional problem. It's not something you can just break down and say it's this or that. Having said that, just to force the issue on what Cliff was saying, if we don't have candidate system use cases, why not take up already published stuff from the big guys like the Epic model or Ponte Vecchio or NVIDIA's systems, and say, if you have to build that outside of those companies, what is it going to take?
Mm-hmm.
Yeah, so yeah, that's why the cost model spreadsheet kind of stopped at addressing that big choice loop on packaging and what is it that it puts, what your choice of system, what kind of substrate it puts you in, what kind of
David, your cost model is way out of date. It's not got the real information. The big semi guys, for example, they have all the information. They have whether it's TSMC's pricing, it's all different. I mean, Broadcom pays way less than we do if you're outside, right?
Yeah.
So it's all that's not the real problem. I think this particular issue was it would cost you more money, right? And more risk, right? To make a decision 2 years ahead of time to use chiplets. And that was That was a fact of life. It's not about the model, right? These people are very smart, right?
Yeah, I'm not. I fully agree with that. I'm not sure if it's coming across that I'm trying to make the opposite point. I'm just kind of trying to give you some background on what the, at least I was in a couple of meetings, what I understood from the thinking was. I agree. There's a lot of risk, a lot of difficulty in choosing a substrate given the A technology and committing to that. I fully agree with that, and I know that the numbers are there, not meant to be representative in any shape or form of anything. They're just numbers, kind of to give you a way to play with, something to play with. The costs are going to be different for everybody, right? They depend on the volume, and really getting those costs, you have to talk to the vendors, right? Nobody's going to publish a cost.
Yeah, that's true. Coming back to,
I mean, that's right. I mean, I think that's total. Then I think we're in agreement. I mean, I think that everybody, all the large companies already have all the information, right?
Yes.
Because the vendors are anxious to sell to them. They'll give them, for large companies, they get the best pricing. And right now they're saying, the cost benefit, at least on the smaller die, right, isn't there, right? Now, if you're trying to do Ponte Vecchio and you're trying to build ChatGPT, then in that space, the very, very high performance space, clearly, these people need to break up their chips. They need to use chiplets, and pretty much everybody, whether you're a startup or whatever, your decision is really made. You don't really have a choice. If you're going to build something bigger than the reticle, right? You got no choice, right? So you're going down that road anyway.
So just trying to knowing that this is we're almost at the top of the hour. What I've heard so far, I think we have a good number of ideas of what we could be doing, and Bobby was right that we're looking a lot at kind of the problems that they're out there. I think it would be great maybe that we use the next meeting to say this is really the things where we can make a difference, and rather than talking about the problems, to get to some solutions. And one way to possibly do that is through the use cases. I personally think there's still a couple of steps to be taken if you have a use case to then link it back to business issues to then get to a solution. But hopefully we can try to do that next time to talk about some specific initiatives that we can focus on.
Yep, I think the use case is a great idea.
I'm going to second or third that. In my opinion, without at least 1 or 2 use cases to guide the way, we will not succeed. We'll just spend our energy.
Okay.
Yep.
That's good. So then maybe
maybe the smart link is a good idea to chase. Right. So
James here. I just joined. I think joined today. But is this slide available somewhere so I can follow up?
A summary of what we've discussed?
No, the slide that you're sharing here.
Okay, yeah, I will send out those slides to the ODSA list.
Oh, you mean the group? I got the email you sent to the group. Is that on the group?
Yeah, I haven't sent it yet, but I will send it to the group after this meeting.
Okay, sounds good then. Yeah, I just want to catch.
Absolutely. Okay.
Appreciate that. Thank you.
Yeah, no problem.
Right. Yeah. Bye bye.
Okay. So yeah, I think then we have a plan of action for next time. Thanks everyone for joining all the good discussion we had.
Oh, okay. So I send you my email then?
Yes, you can do that too, and but I'll send it out to the broader email list anyway.
Okay, sounds good then.
Okay, awesome. Thanks everyone.
Hey, thanks, Marek. This is nice.
Sure. Good. Yeah. Okay.
Thank you. Bye bye.